Hey everyone, today I have some really awesome, and I mean awesome, news for you. A recent U.S. Geological Survey study published in the journal Science documents some of the most recent findings of NASA's Mars Reconnaissance Orbiter on the Red Planet. It's been known for quite some time that Mars has water ice. The first pictures of the Red Planet, albeit somewhat grainy, clearly showed its north and south poles tipped with the unmistakably bright white of massive polar ice sheets. However, for many years, it was believed that most, if not all, of Mars's water was restricted to these distant, brutally cold polar regions. For any future Martian colonists, this was ominous news. It meant that the most valuable resource, water, was going to be hard to come by. A Martian colony faced two options. They could either settle near the poles where the water is close at hand, but the temperature is insanely, absurdly, dangerously cold, or they could settle in a warmer region where it's still kind of cold, but it's much more tolerable. It'd be closer to the equator. However, water would be so distant that it would have to be brought in with thousands of miles of pipeline feeding from the ice at the poles. Neither option is particularly appealing. There's enormous logistical challenges with each option. This is why the recent study is so exciting. By using the high-rise camera on board the Mars Reconnaissance Orbiter, planetary geologist Colin Dundas and his research team were able to observe 8 regions of the Martian surface, 8 regions where erosion had swept away the upper layers of soil and dust to reveal what lies beneath. It turns out that hidden just a meter or two beneath the surface isn't bedrock, it's ice. And not just a little bit of ice either, but massive sheets of ice that in some cases extended close to 100 meters down into the crust. If these 8 sites are any indication, then it could be that much more of the Martian surface is water ice, covered by a thin sprinkling of red soil. The implications of this discovery for future colonization are numerous, and I'll explore them in a second. But first, the critical details. These 8 sites were all positioned at high mid-latitudes, around 55 to 60 degrees latitude north and south of the equator. Now, these areas are still relatively close to the poles, and they're thus still dangerously cold, but they're measurably more tolerable than the unforgiving chill near the poles themselves. Furthermore, this ice is relatively pure, not entirely, but decent enough. It's theorized that over millions of years, layers of snow were deposited as a warmer, wetter Mars went through its seasonal cycles. Rock and dust occasionally mixed into the snow, but for the most part, the sheer weight of endless winters' worth of snow compacted the frozen water into relatively pure sheets of ice. So what does this mean for potential future colonists to the Red Planet? It means they can establish their colony closer to the equator while still having plentiful water reserves on hand. Although it's believed that near the equator the warmer temperatures would have thawed out the upper layers of the soil, so any extant ice would necessarily be buried deeper into the ground and would thus be harder to access. There could potentially be a sweet spot somewhere on Mars, a water-based Goldilocks zone, if you will, where tolerable temperatures and accessible water coalesce to create a nice little spot for human colonists. Because the ice sheets are relatively thick, they provide an opportunity for subterranean shelters carved into the ice and thus shielded from radiation and protected from Martian dust, which is extremely fine and ruinously statically charged. The particles apparently get everywhere, and they can be a huge hassle to deal with. Because the water ice is relatively pure, it will also be relatively easy to extract it and turn it into usable liquid water. Water that can be split to yield hydrogen for fuel, and molecular oxygen to breathe. It can also be made into water that can be used to cool nuclear reactors, water that can be used in hydraulic pumps, and most importantly, water that can be consumed to sustain life. The takeaway message here is that Mars has far more water than we once thought, and the geographic distribution of this water and its relative purity are all encouraging signs for the logistical feasibility of a permanent human colony on the Red Planet.